All right, hello everyone. Today I'll present our research, which is titled, um, don't remember exactly which title I gave it, something like Blocking Unwanted Destinations of Fitbit Applications, I think was the announced title for this talk. And the idea is, I guess, known to everyone who have been using wearable fitness trackers, which I suppose most of us, is that they share lots of information as expected with the manufacturer, but also may share some other data with some of the third parties that perhaps you would want to kind of avoid. So we would like to block these unwanted destinations, but when we do that, it may be that we might break the applications, the companion applications or fitness applications, wearable applications, whatever you want to call them, because obviously if developers of the apps envision some kind of a connection, and if we disable it without sort of explicitly without them testing that first, it might happen that the apps stop working, and of course we do not want that. And finally, we want our solution to do that, so to block those third parties without breaking the essential functionality, to be as easy as it can be for an average user to be able to install it. Because if it's some complicated solution, some complicated approach, perhaps like a regular user would not be able to comprehend and to set it up. So in simple words, we would have something like this, the usual scheme where data is collected on a wrist, then is sent to the app, and later is synchronized to the cloud where the manufacturer stores and analyzes it. However, sometimes, as we said, the data might be sent to someone, to understand third party. It may be a weather provider, advertisement provider, some analytics services, I don't know, maybe social networks and whatnot. And here we have an example of the data, like I cherry-picked the most sort of quote unquote sensitive data that has been shared. And you see like the details that have been leaked to some unknown third parties may be very devastating. For instance, the included data may have gender, age, even lifestyle. So if you don't take a lot of steps, it will output sedentary, otherwise it will put active. May also have an email as well as even precise location, which if you like put it in Google Maps, it will point directly to your house. And some more, like for example, advertisement ID, which is consistent across all the mobile applications of Android, and therefore it can be sort of tracked beyond the current applications that you are using. Obviously, such is a big concern. I would like to eliminate any of those kind of leaks while preventing the app from breaking, so to make sure that it works correctly. And previous works have investigated blocking of unwanted destinations for general IoT devices. And while they proposed a solution that automatically analyzes connected third parties and chooses which one to block or which one to allow, while it sounds very promising, it's not very applicable for the case of Internet of Sports and wearable devices in particular, because first of all, it requires additional network equipment to be installed on top of the app. So it could be like a router, that sort of a gateway router that will filter data there. And of course, it would be not very effective for non-stationary devices. So for instance, for like a smart TV or smart plug, which is constant in one's apartment, it's fine. But if you're like walking with a device and connecting outside of your home network, of course, it will not work. Also, since we sort of manually choose, well, not manually, but we are the final authority on whether or not to block or allow the servers to function, it's likely that it may result in higher high number of false positives. So it means that basically we block something and it turns out it was vital and it breaks functionality. And lastly, the proposed solutions are challenging to set up. It requires like a specific router for specific class of devices, etc., etc. They are not cheap, or they're like, well, they're not even available for sale. They're not commercial. They're like sort of prototypes. So it will be quite a challenge if a regular user would like to set kind of the solution up. Therefore, we try to find something that would work for everyone, and we got heavily inspired by ad blockers. So I assume like most of you and like a huge chunk of the population uses ad blockers, and they appear to be extremely effective, not at just blocking the unwanted content such as advertisement, cookie pop-ups, etc., but also at not breaking the website. So we can still browse without seeing what we don't want to see. And of course, if we consider, ad blockers rely on internal block lists, where block list is a set of host names that we would not like to visit. So in our approach, we consider such hosts as basically an unwanted third party. So if a host name is in a block list, we say that we don't want to connect to it. And in that event, we are not the authority who says, okay, this is an unwanted third party, we do not want to connect to it. We instead kind of sort of outsource this decision to the existing block lists that are well maintained, well operated, they are well supported and well tested. So of course, it is likely that such approach would yield a much lower number of false positives, since those block lists are continuously maintained, and likely if such cases occur, basically benign host lists would be removed from the block lists. Finally, our approach does not require any additional equipment. It's low CPU consumption, low resource consumption. We can sort of set up manually how many block lists we would like to have working. So we can basically use every single block list available, but of course, it's likely then in that case, you would it would result in a high chance of the apps breaking. So we can manually customize a kind of a trade-off between how much privacy we want and how low we are prepared to tolerate the risks of apps not working. And of course, like anyone can set up an extension in Chrome and Google, so it's not a problem for average user to install and use ad blockers. So in our approach, we consider an official Fitbit application and another 6 partner apps, which offer various fitness services, such as general fitness applications, runner applications, distance trackers, etc., etc. So first, for our experiment, it was required to have two smartwatches, 2 phones, and a Wi-Fi hotspot. In order to discover what third parties have been contacted by the devices, we set up a man in the middle between the companion application and the cloud. And for actually blocking those third parties, we utilize a block list of one of the most popular content filtering extension, uBlock Origin, and another big block list collection, which is called Fireblock. It's sort of not as well known as uBlock Origin, but still it's well regarded in the circles of privacy activists and those who advocate for like free and open internet. In order to disable those connections, we utilized we modified the host file. Host file is basically a file that is present in most of the operating systems, and it's been looked up before DNS. So before, essentially, when we type the domain address, it first looks at the domain address in the host file, and if it's absent from there, it then will try to resolve the domain to the IP address. And if in host file we will set this domain as 127.0.0.1, it will essentially prevent the system from contacting that domain. And since our internet is shared via Wi-Fi, if phone contacts it, it goes through Wi-Fi hotspot to a computer, to a laptop, and then laptop here looks up host file, sees the unwanted domain, and basically drops the connection. All right, so let's see what our results were in terms of what parties are being contacted by the apps and what data are being shared. So yeah, as already I mentioned, like kind of data is like the shared data might look very concerning in terms of how private it may be, and we know that most of the apps share basic details to all of the parties, such as what is the phone, what is the manufacturer, like screen resolution. But sometimes they share even more private data, such as email, connection details, is like whether or not it's a cellular network or Wi-Fi network, location of the user, even demographics, and some identifiers, most notably Android advertisement identifier, which is sort of a unique identifier. It can be reset, but it's still constant across all the services for Android. So for instance, if, I don't know, let's say I'm using a Fitbit app and have my AID, but I'd like to remain anonymous, and Fitbit gets, or like whoever third party is being contacted while talking to Fitbit, and if they get my AID and they have like some other source of ID from some other apps, they can sort of connect the dots and link me to my other profiles and essentially de-anonymize me. And yeah, basically most of the data has been shared to big corporations such as Facebook, Amazon, Google. Guess no big surprise. And for like, we do not sort of focus on that part in our research since it's been done in other works, our works. So yeah, you can look them up if you're interested. We also study what are the most contacted entities, not, and yeah, as I said, unsurprisingly, mostly it will be like Facebook, Amazon, Google, but some others also, which has been used not only by fitness applications, but other applications, mobile applications, and yeah, lots of fitness, lots of sensitive data, including fitness data, even have been leaked to those third parties. And our results suggest that all study types contacted at least one unwanted destination, and then a vast majority, like overwhelmingly vast majority of contacted third parties are unwanted, so they've been contained in a well-regarded block list, so should be disabled. And finally, more than 50% of the unwanted connections are contained in the default installation of uBlock Origin, which means like you press one button on your, if it would be like a browser application, if you just press one button and you automatically filter 50% of the content without sort of hindering the usability, which is, I guess, surprising. So yeah, we found that all of the data is, a lot of the connections are unwanted, quote unquote. So we wanted to verify if it's, so we wanted to verify once we disable those connections, whether or not the application still can function correctly. So we run 2 rounds of experiment. In the first round experiment, yeah, let's put it this way: we run an experiment where a user wears 2 bands on the one hand, 2 smart bands, like located closely to each other on the wrist. Where for one band we use it in off-the-shelf mode, so everything that was envisioned by the manufacturer is present. We don't block anything. It connects to all the third parties and like limitlessly. And for other bands, we disable all of the unwanted connections that are being contained in those block lists of uBlock Origin, Firebox, all these content filtering extensions. And then we sort of test the difference between both devices. But of course, in that event, one might argue that what if there are some errors due to wrist placement? Because obviously, those devices are not located at the exact same spot in the wrist, and as a result, there might be some errors, some miscalculations, etc., etc. So even if the data differs, it's not enough to say, oh, that might be because XYZ. So therefore, we run another round of experiment where we repeat the experiment, but for both devices, we use them in off-the-shelf mode just to assess the baseline difference. So once we do that, we sort of can compare the difference between 2 clean devices and one clean and one modified device. And comparing the 2 differences between 2 rounds will sort of be enough indication to conclude whether or not anything changes when we block those third parties. We assess the most relevant metrics as been proposed by a recent survey where people were asked why would they want to buy a wearable device, wearable fitness tracker. Mostly people answer, okay, we want to measure our steps, our exercise, our sleep, etc., etc. So we consider the most relevant metrics. We run both rounds from Monday to Friday, 1 working week, and then we compare the difference. Our results suggested. So yeah, this is sort of a table that is summarizes the results. We calculated root mean square error and normalized root mean square error between both rounds, and we compared them. Our results suggest that there is no significant difference between both rounds. However, we were able to identify that steps has the lowest error for both rounds, but overall the error is comparable between 2 rounds, and there is no indication that disabling third parties affects the metrics that have been measured, which is kind of expected. So in simple words, like, I don't know, I disabled connection to some Amazon ad systems, and it doesn't appear that my step count broke or whatever. All right, so we claim that our solution is easy to use for the average users, while the previous are not. And how one would do that? Therefore, we studied what are the most, we used 2 big block list collection, again, uBlock Origin and Fireblock, and we studied what is the most quote-unquote best block lists available. So the block lists that contain as many third parties that are being contacted by verbal applications as possible. And since this Fireblock is more sort of like gimmicky, tech-oriented platform, indeed, they have many more block lists that are higher hitting than uBlock, but nevertheless, basically the best uBlock block list is placed only 6, I would say. I suppose that's not surprising, but having those best block lists that are most hitting, that are most applicable for our case, it is possible to utilize mobile ad blockers, quote-unquote, mobile filtering extensions, mobile apps that enable users to manually select their block list that they would like to use and run them in, well, on the Android system. Furthermore, those solutions are working for both rooted and non-rooted phones. So therefore, regular users, even though they do not want to root their phone, they don't know how to do that, they can still use those apps and be able to enjoy their ad-free, privacy-friendly varying experience. And yeah, on the screenshots, we show an installation of Otherway, which by the way have a list here, if you can see, like which was ranked 3rd. Also comes from Fireblock, and Otherway is a open source ad blocker, where we input the best block list for our case, up and running and working as a clock without breaking the mobile applications. And in future works, for our case, we would like to assess how our solution would impact the battery life, how much network traffic we can save, because if we do not contact those third parties, naturally we don't send them either GET or POST request. It would save us traffic. All the payload that doesn't circulate between the device and third parties, it's megabytes of data. And for those who have a limited internet plan, that would be, I suppose, a great addition to the increasing privacy levels. And finally, since we are working on the topic, we also might release our own dataset, because even though our approach was like 88% effective, there's still maybe 12% that can be added up. So we might be able to contribute and to propose more refined block lists specifically for the tasks of blocking unwanted destinations for Internet of Sports application. Yeah, I guess that's it. Thank you very much. And if you have any questions, don't hesitate to ask. Thanks.
Thank you, Andrei.